Okay, hello guys. This is Jacob from GoodWe Solar Academy. Today we will have a topic about the residential solar storage system of development. Here today we do not have so much technical things. Just we share our idea how the solar storage system in residential market developed, and what is important for residential solar storage market. Okay. We can start. We start now. First, I want to give a brief introduction about the nominal residential solar storage system. What type of systems existed in the market? The main system. What we can see now first is also the most popular system is hybrid. The hybrid, it means all the solar and battery and grid, also the load is all connected in the same system, in the same unit. The inverter, the solar storage inverter, we call it hybrid, because all the components, all the units like a solar battery, something, the AC part, the DC part, is all connected to the same inverter. So this is a hybrid inverter. We call the system is a hybrid system. So this system is the independent system. So it does not need to work with the existing solar systems. It can build the solar system and battery system together. And another one is also popular, but it's for now I can say it's not so popular like a hybrid, because this one is we call it AC coupled system. AC coupled system, it has to work with PV inverters, because AC coupled inverters actually it's it's not the new energy system. It has to work with solar system. They build up the new energy system. We can also call it battery inverter. Okay, battery inverter or battery system. Okay, so AC coupled inverters, it cannot used independently. Okay, you have to use with PV inverters, because without the PV inverters, it cannot. It does not have solar. Okay, for AC coupled system is also popular, like like in Europe. Okay, SMA, also Tesla. It's all have AC coupled systems, and they mostly they use AC coupled system. They do not have hybrid. Okay, and for hybrid systems, most of the manufacturers, I can say, they have hybrid systems. They also have AC coupled systems, but mostly hybrid is most popular one. So except for the hybrid system and AC coupled system, the in market we can see also a lot of different systems, like the standalone system. We call it off-grid system. Off-grid system, it means it does not interact with the grid. The inverter can connect to solar, can connect the battery, and can support the power of from solar and battery to the consumer, but it cannot export power to grid. And normally they cannot import power from the grid to charge the battery. But some of off-grid systems, they can get power from the grid to charge the battery and also to support the load, just cannot export. So it has different standalone. So for standalone inverters, normally for now, for residential, the capacity of the system is just not so high. Normally you have 1 kilowatts or 2-3 kilowatts something. But for hybrid and AC coupled inverters, now we can see the residential, they have maximum 10 or even 20 kilowatts of systems. Okay, this is the standalone. And for standalone systems, I think representative manufacturers for standalone systems, I think we all know they have like SMA, like Victron. Okay, they're all very famous about the standalone systems. And the another system is actually it's not just a setup system. It's a system about the energy management, except for solar, battery, and also the inverters, grids, and the loads, also integrated by a control system. We can call it EMS system or VPP system, something like that. Okay, so this one is we cannot say it's not a standard system. Yeah, because for energy management system, it can be different, very different for different sites. Okay, so about the details we can talk a bit later. For now, we can see the most popular 4 types of solar inverter or solar storage inverter in markets, in the residential markets, is just like this 4. Okay. And another topic here, we can talk about the operation scenarios in the residential solar market. Okay. Normally, in the residential solar storage systems, most of the important scenarios is the self-use. Self-use, we can also say it's a self-consumption. Okay, self-consumption, it means the solar productions will be support the load first, and if they have sufficient power, the excess power will charge the battery, and the rest will be able to export to grid. Okay, export to grid to get a FIT, and charge the battery or support the load to decrease the import power from the grid. So this is used in the scenarios or the countries or the areas with the higher electricity cost, like Australia. Australia, the high cost, the electricity cost is very high, and also in like America, also in some of the European countries, most of the use of solar storage system is about self-use. That just increase the self-use of solar power and decrease the import power from the grid, just to save the bills. Okay. And another one is backup power. Backup power, it's also a scenario. Its scenario is for the countries or some scenarios without stable electricity power supply, like in South Africa, like in Southeast Asia, some countries. The electricity power system, the public power system is not so stable. Sometimes, maybe, one time 2 days, one time 1 day, or maybe even a few times a day to get a cut off about the electricity power supply. So like in this place, they use battery and solar to, they can save the solar power into the battery. Okay, and when they during the cutoff, to use the battery to support the loads and the important loads. Okay, so just in case during the cutouts, during the electricity cutoff, there's no power in their house. Okay, and except for the scenarios without a stable electricity, also in some place like America, like in Japan. Also, I think last year we all know that in Australia there's the big fire, right? There's some, very special, very, like nature hazards, like typhoon, like the fire, something like that. Like in America, like in California, okay, they have the natural disasters happened, very natural, like the storm, like the big fire, something like that. Okay, in this place they also need the backup power. Sometimes before they all use the generator to support the load during the cutout, but during the cutoff, but the cost is high for generator, diesel generator or something like that. Okay, for now, if you use solar, they will change the generator to solar and a battery, the solar storage system. Okay, so backup is generally, just in short, it's for power supply security, right? And then alone is another scenario. like the standalone system. Actually, is in some places, in some islands or some far away place, they do not have public electricity. Okay, actually, like in Australia, I think in Australia there's a lot of requirements about the standalone systems because in Australia there's in the middle, in central Australia, there's not so much populations, but the place is very big, it's very broad. Okay, so if they want to reach the public electricity, the cost will be very high, because they have to build up the power systems for a long way to the house use. And the cost is very high. And so sometimes in the central place, in the faraway place, they do not connect to the public electricity systems, just to decrease their costs. Okay, and also another is about the time of use. Time of use, we also call it TOU. This is for the place where with the steered or with time of use electricity charge theory. Okay, like in some places in America, Europe, in some countries, and also in Australia, in the morning the load power is very high. For the house load is very high, and in the middle in the middle of the day, like the noontime, it's not so much demand for the electricity use in the house. Okay, in the twilight time, the electricity charge will be high again. So like in this place, we can use the storage to save the power from the PV at noontime, and to discharge, to support the loads, and to decrease the electricity cost during the morning and the twilight. Okay. And also they have other operations like V2G, V2H. This is all new applications. It's not so much used for now, but we can see in the future, it could be very popular. I also like the EV charging, microgrid system, and the community power systems. Like EV charging now, it's more and more requirement about that, but it's not so popular now. It's just get higher attention for that. And the microgrid systems is always popular, but before it's used in some big projects, like in CNI scenarios, or used in a garden, in a utility community systems. So it's a big system before, but now a lot of the system providers, they put the they adopt the microgrid systems to a house, or to in their community systems. Just a few houses. Between few houses, they can build up a microgrid, or they build the VPP systems like that. Okay. All right. The next topic we say is the residential solar systems. So we can say for now, the solar storage system in the residential system scenarios is very popular, but it's just still a new one. Actually, it's for the whole market, for the whole global market. It's still new. It's not so long time. Okay, still young. So a lot of people maybe will think about that. Think about how the residential solar systems goes. How they developed. In the future, what will be different, right? Of course, we cannot tell exactly what will be different in the future. Maybe in 10 years, 20 years, what is the difference? We cannot tell. But from these scenarios, from the usage of the residential solar system with battery, we can give some guess. Maybe we can guess the trend, okay, the potential about the solar storage systems. Okay, The first we can talk is utility friendly. Utility friendly, we can say it's actually it's really a trend, especially for the developed countries like Australia, like Germany, like America. Okay, a lot of the countries, they want to control, or they want to reserve a function to control all the new energies, like a solar, like also it's not just a solar, also about a wind, something like that, new energies. Okay, because if the new energy build up too much, and the production of new energy will be injected, okay, injected to the public grid, and we will have you know somewhere have a great effect to the public grid stability. So how to control the new energy production and how to combine the new energy to the public grid systems healthily, friendly. This is could be very important. And for now, we can say, like in Australia, they required the IED, the draft function. They also have a new project request like FCAS. This is all about the frequency control. It means if the utility grid frequency is lower than normal, then they can have a mass control, of all of the systems to discharge the battery to make sure the frequency of the grids will increase to a normal range, okay? Something like that. Now, also, if the frequency is lower, is higher, then they will decrease the in production from the new energy or charge the battery to lower the frequency to a normal range. Okay. Also about HAMS in Japan, RCR in Germany, and frequency control in a lot of other countries, it's all like that way, right? And also a utility control is also used in the VPP systems. Now a lot of VPP systems, the controller provider, they will be able to communicate with the electricity or utility company. They get the data from the utility company about the real-time status of the grid system or a public grid system. Then they can control the new energy production, battery charge or discharge to make sure the public grid system is stable and healthy, right? And another topic is the second life, reduced battery, okay, recycling of the vehicle batteries. For now, it's not used too much because of the security of the second life batteries. But in the future, I can say it could be very popular because about the electrical vehicles. For now, they use a lot of vehicle batteries inside, but maybe 10 years, 15 years later, again, how the government or how people handle the old batteries, old vehicle batteries. The best way, of course, is recycle to reuse it, right? So to reuse it is the best way. I think it is used to the storage or use maybe other way, but I cannot see so much. But I think it could be very popular in the future to use the second life batteries to the storage systems, because if the vehicle batteries is not used, because of security or because of capacity, everything, I'm not sure. But if you used in the storage, it can still work. And for now, a lot of there are already some users and some installers that have tried recycled battery, and I didn't hear so much dangerous or security problems, something like that. But yeah, we cannot say there's no security problem, but I think it should be okay. And in the future, maybe if they have some problems about a second life battery, I think it could be received, it could be handled, Okay, the third one is the multi-source integration, sources integration, like the solar system, battery, also the public grids, also the generator, and sometimes they can integrate the wind production into one system. Because for now, public grid system, if the cost could be high, and sometimes it's not stable. But solar power and wind power is also not stable. Okay, but generator is stable, and a battery they can use it for backup. So if we integrate all the power sources into one system, and they can work together healthily, then it could be very, very popular, and they can handle resolve the problem about the power supply security. Okay. And the last one is the energy management system. And the energy management system is not a solid system. It's just it's a invisible system, we can say. Okay, because like the VPP microgrid, okay, if they adopt the energy management system, the solar power use efficiency and self-use ratio will be very high, and they can increase the self consumption, and also they can keep the utility friendly function, and also they can integrate all multi sources together. So it's not a solid system. It could be very different. And in the future, just my idea to say what we should do for the manufacturers of maybe battery, maybe inverters, maybe the solar panels, everything. Okay, so what we should do in the future to make the solar storage system more popular and more stable, more believable, right? Maybe the first thing is about the protocol things. The protocol things is that the battery, how the EMS controller, how the different source works together. They have to communicate with each other, okay, to make sure they work together very well. But for now, different manufacturers and they will follow different software protocols. Okay, for now it's difficult. We can say for now the standard Modbus protocol, we can, if Modbus RTU, Modbus TCP or some spec, we can see that, but it's not enough. It's not enough because there are still a lot new manufacturers if not integrated inside it. Okay, so maybe in the future. It's not the installer efforts. It's not the user efforts. I think it's maybe the government's efforts to unite the protocol types and just make sure the protocols will be very standard, right? Like in the future, if we will buy a brand of the inverter, and we can buy any of other lithium batteries to use together. We don't have to do another work, and we can use another controllers to communicate with all of them and to do the monitoring, to do control everything, right? About EMS systems. This is very difficult, but we expect a better status, a better situation in the future. And another is about the control rate and the control accuracy, about data accuracy, especially for the big projects, the government projects, because they have to keep the grid stable, keep the power supplies secured, and also they have to make sure the whole system is secured, right? So about the data, the running data of the systems, like the pure production, like the battery capacity, battery charge discharge ability, also like the grid frequency, grid voltage, and the grid power, meter power, everything, right? So we can say more accuracy about these data for the EMS systems and more opportunities for the manufacturers and for the system providers, actually. Like for now, we already have such, we can say it's not a problem. We can difficulties, actually, like in British, there's comment about the FFR, I think it's like that. And also in Australia, it's FCAS, and in other places, something like that. The projects like that to apply for such usage of the system, you have to keep the accuracy of the data of the system, okay, of the system data to a very limited range, and also the power rates could be very high, like the battery charge discharge rate, like the inverter production ramp up rate, ramp down rate, something like that, to react to the load consumption and to the EMS controller commands, something like that. The speed could be very important. Okay. And another one is about the system, privacy security. I think we all know that the productions, if we build a system in the house and the usage of the loads, the house loads, the usage of electricity and battery charge discharge data about the house system actually is very, very private for the users, actually, because if this data is leaked, maybe someone will use that to guess what's your habits, right? What your daily habits. That could be dangerous. Okay, for now, like in Europe, they have a GDPR requirement. If you have the data transfer or wireless communication, monitoring, everything, you have to comply with GDPR requirements, right? Also, like in America, they also have the Customer Privacy Protection Act, and also in Australia, it also have such an act, but it's not so broadly used. But in the future, it could be used, and it could be very important. And the last one is battery recycling and reuse. And this we have talked before. This is difficult, but in the future, it could be very important, right? Okay, so this page we just give a summary. Okay, summary why we use the storage, why we use the battery in the solar systems, right? To use the battery with the solar, we can have access to cheaper power. Cheaper power, it means that you can import late power from the grids, and you can increase the self-use of the solar. And in the future, I think the cost, the system cost of the solar and the storage systems will be decreased very much. Then you can use much cheaper power if you install the solar and with the battery. Of course, if without the battery, it's another way. It's another topic. If without the battery, the PV production is not stable. You can say not stable, and it cannot 100% perfectly match with the household's use. So you have to use the storage to shave the higher production of the solar, to shave the loads, to make sure to match the load consumption and the PV production, as much as possible, right? And the second is safe. Safe power, it means in the place with the natural hazards, like we talked in Japan, in America, in California, and also in the place without stable electricity power systems, like the Africa, right? So the systems, if there is sun, there's power, right? So if you use solar and battery, they can reduce the solar power to supply the household consumption, even without the public grid systems, right? And next one is green power. green power, of course, because it's new energy. It's not a fossil power. So in the new energy, I didn't calculate how much we can save. We can save the environment. Okay, how much we can save the environment if we use the green power, we use the new energy. But I think it's there are a lot of calculations in the in business. You can check that in Google. You can check that in YouTube. There's a lot of calculations, a lot of explanations about how and why we use new energy systems. Okay, and another one is about efficient power. Okay, the efficient power, it means actually the solar system and battery systems. Even solar with battery, installed with battery, they can used in multi-source, in microgrids, in VPP systems, and also in the energy management systems. It could be much better, right? If without the battery, you can just limit the production of the solar, but you cannot increase the power of the solar, right? But if with battery, it can charge and discharge to balance the production of the PV and the load power, and have a much efficient response to EMS controller systems, right? Okay, so today is the topic. Maybe, I'm not sure if you guys have any questions. I see there's a question. You asked what's the difference between the hybrid inverter and the off-grid inverters. Actually, hybrids, we call it hybrid because the integrated the solar, the new energy, like a solar, like wind, and also the battery, the storage system, solar system, and the grid system, also the load system, house load systems, into one unit. So this is into one inverter. So we call it hybrid inverter. For off-grid inverters, it cannot integrate grid inside because it cannot export power to grid. Okay, this is the structure difference. About the usage, normally for now, as we can say with all the manufacturers in the market in Europe, in Asia, also in America, the off-grid systems normally the capacity is lower. The capacity is lower, not so much. Like hybrids, you can reach 20 kilowatts or even 30 kilowatts. Like in Germany, the new EEG Act just released the limitation about how to use solar systems. Before it's 10 kilowatts, but for now it's 30 kilowatts, right? But for off-grid systems, the production of the solar could be limited because it cannot export to grids, right? It cannot get FIT. But for the off-grid, there's one thing is good because it do not have to spend so much time to apply for the grid interaction, the grid connection. You know, for in Europe or American countries, for the application fee to reach the authority to connect to the grid it's also very high, right? But for all grid systems, you don't have to spend so much time and the cost to apply for the grid connection. So it's just the brief differences. Okay. There's another question about the plan for virtual power plants, the GoodWe plan for virtual power plants. Actually, in the virtual power plants, in VPP, solar inverter and battery is just one of them, okay? Because they can use another source, and also they need the most important thing is they need a controller, a smart meter, something to control all the systems. And for the BPP, actually, it can communicate with the grid company, utility company, to gather the data and to do the analysis when and how or how much the battery should charge and discharge, and when the solar production should increase or decrease, should limit it. Okay, for now, if you ask about a GoodWe, I think the way we will do that is cooperate with the third party controllers. Like in Australia, we have a lot of partners of the controllers, like switching, like deposit. Okay, we work with that, and also we also work with the remote control VPP, like with Evergen. Okay, we work with them. It's also our partner to realize the VPP systems, right? And also another question about the GoodWe's plan to increase the internet security for the inverter. Actually, I'm not sure the internet security, you mean the monitoring or something? If you mean the monitoring, actually, we are updating our the monitoring units, like the Wi-Fi module, LAN module, and also we have other new methods about communication in the future, like 4G, right? So in the future, we will have multi monitoring options. But if you mean the security of the private data, then it's another topic. But for now, we have built up the local server in a lot of places, like in Europe, we built up a server in Germany. In Australia, we built up a server in Melbourne, and also we will build up a local server in America to make sure the data is integrated in the local place. It will not be leaked outside. And also we will also work with the GDPI, with the privacy, Customer Privacy Protection Act in California to adjust our systems, our management systems, to make sure the whole system is complying with such a requirement, right? Okay, so that's the topic today. Thank you, guys.